If you look down your SMT line, for most of it, it's relatively easy to know when you have a problem. Now, fixing the problem is another story, but in general, we've developed tools like SPI and AOI to help us catch the majority of our issues before they become a big deal. Things like solder paste misprints or pick-and-place issues or component issues like tombstoning. However, that's not really the case with cleaning. Don't get me wrong, there are a lot of tools out there to help us measure specific quantities, but if you think about it, there is no unit of cleanliness for reliability. I mean, we can talk about the surface concentration of a particular contaminant in micrograms per square inch, but knowing the implications on the reliability of the circuit board can be much more challenging. To put it as a question, how clean is clean enough? Today, I want to talk about the steps you can take to help answer that question for yourself. So imagine this. You're either an OEM building a new product or a CM who's taken a new contract for a build, and one of the requirements for this build is assembly cleanliness, for whatever reason. Maybe it's ending up on an airplane or in a car, or operating in a harsh environment. Whatever that reason may be, reliability of that assembly is key. Now, I don't think I have to do much convincing that a dirty circuit board will have much higher chances of failing than a clean one. There are many published studies showing how the presence of contamination on a circuit board can lead to failure mechanisms like electrochemical migration, significantly shortening the life of a product. So how does one measure cleanliness to make sure they maximize reliability? To help simplify things, let's ask a slightly different yet related question. Will the product I'm making survive in its intended application? Now, since there are about as many applications as there are products, we as an industry have put together a set of standards to make answering that question easier. These are the IPCJ standards, like J Standard 001 or J Standard 004. However, we're still not out of the woods because according to J Standard 001, Section 8 on cleaning and residue requirements, we must provide objective evidence that the hardware will not be adversely affected by contamination in its intended application. So basically, we need to figure out ourselves that the circuit board will survive. On the surface, this seems very inconvenient at best. But if you think about it, it makes sense. Not all assemblies see the same environments. For example, a circuit board in an electric vehicle shouldn't necessarily be subject to the same cleanliness standards as a computer processor going into a server farm. So to answer the question for our specific boards, you can do one of three things. 1, provide historical evidence. 2, you can provide simulated life testing, which basically means putting your boards in a chamber that simulates temperature and humidity. Or 3, do SIR testing. Now, for those of you that have historical evidence or have the ability to perform simulated field testing, those will provide a more realistic view of how the boards will behave in the final environment. However, for those of you who don't, SIR testing is the way to go. Now, the steps would look something like this. First, you design your cleaning process. This includes everything from the cleaning machine to the cleaning chemistry, temperatures, nozzle pressures, belt speeds, etc. Then, you make a batch of boards with this process. For SIR testing, normally coupons are used instead of the actual board for cost reasons. Those coupons are then tested by SIR, and if they pass the 10 to the 8th ohm limit, then the cleaning process is considered sufficient. Those boards would then be subjected to ROSE testing or something similar to measure process control limits so that you don't need to run SIR on every batch you make. And that's pretty much the gist of it. At times, the data analysis can be daunting, but in the end, having a reliable cleaning process will be worth it. Alright, if you like that content, make sure to hit the like button and subscribe. You can also click that bell icon to be notified of future episodes. Now, if you have any questions, feel free to leave them in the comments below or send an email to AskDrAdam@KYZEN.com. Thanks again, and stay clean.